Alright, so hopefully you've had some time to complete the lesson 1 skills practice on classifying angles. If not, feel free to pause the video and practice some more. We're going to go ahead and move on though and take a look at some of these problems and review them. Okay. Beginning with the first section, naming each angle in 4 ways, then classifying the angle as acute, right, obtuse, or straight. We're going to go ahead and do that quickly with number 1. Angle ABC is acceptable. Angle CBA, angle B, or angle 1. And again, remember, primarily with these first 3, the vertex is our number 1 most important way to name the angle. Oh, let me go back there. One thing we forgot to do is to classify it, excuse me. This is going to be an obtuse angle. Obtuse. And why? Because it's greater than 90 degrees. Number 2, we've got angle DEF, angle FED, angle E, or angle 2. And this is going to be a right angle. We can tell it is because of our little box in the corner. That indicates that we have a right angle. Number 3, so there are the ways to name angle 3. This is an acute angle. It's less than 90 degrees. Acute. Number 4, we've got angle JKL. Now again, this one is a straight line. It appears to be, and therefore it may seem kind of funny that we're naming it an angle, but it is can be considered to be a straight angle. Straight angles and straight lines do have something in common. They're both measured at 180 degrees. So this is a straight angle. 180 degrees. That's going to be really important when we work when we move to the next section. So very important to know that a straight line is 180 degrees. Number 5. And what kind of an angle is this? Looks like it's obtuse. And finally, with number 6, and this angle appears to be less than 90 degrees, which makes it an acute angle. All right, let's go ahead and move on to some more of the fun stuff. Taking a look at our angle relationships. Number 7 through 12 says, refer to the diagram at the right. Identify each angle pair as adjacent, vertical, or neither. So let's look at 7 and 12 to start. Here's 7 and here's 12. Now they're not across from each other. They do appear to be right next to each other. And since they are next to each other, they share a common vertex and a common line. They're adjacent. They are neighbors. Next up, we've got 8 and 11. Now, if we look at 8 and 11, those appear to be right across from each other. Angles that are opposite of each other are called vertical angles. We don't know the measure of 8 and 11, but we do know that 8 and 11 have the same measure. Moving on with 7 and 10. 7 and 10 are also vertical. There's 7 and 10. These are also vertical angles. They are directly across from each other. 9 and 11. Now with 9 and 11, we might be tempted to say that they are across from each other, but it looks like 9 and 12 are actually going to be the vertical angle pairs. So 9 and 11 are going to be neither. Those don't really have much in common with each other. 8 and 9. 8 and 9 are right next door to each other, so we call these adjacent angles. And finally, with 10 and 12, just like with number 10 here, it's going to be neither. They are neither across from each other or next to each other, and that means that they are neither adjacent or vertical. And moving on to our final section. All right, let's take a look at 13 through 18. Angle SYX. Now we're going to use our angle properties, what we know about opposite angles and vertical angles, to figure this one out. Let's take a look. SYX. So here's S, Y, and X, and it appears that we do not know the measure of the angle. That's, of course, makes sense since that's what we're trying to do, what we're trying to figure out. But if you look at SYX, it does have a vertical angle. It's got a pair or another angle it has something in common with. And that is going to be this one right here. Let me highlight it here. It's UYV. Now these two angles are opposite. They're vertical each other, so they have the same measure. So if UYV is 76, then that means that angle SYX also has to be 76 degrees because they're vertical angles. Moving on to number 14, angle XYW. Again, it has an opposite angle. This one right here appears to be T, Y, and U. This angle is opposite of the angle we're looking for, and therefore it makes it pretty easy to find, because if this angle is 40, well, then that means that this must also be 40. In fact, let's go ahead and write these in here so that we know we're making some progress. All right, let's move on to angle WYV. WYV, let's see, WY and V. Once again, almost same exact problem. We've got an angle opposite of WYV, and that is SYT, which is 64 degrees. That means we know this must also be 64 degrees. So we're using this property that we've learned. We know if an angle is directly across from another one in intersecting lines, we know they're equal, and that's what's allowing us to find these measures. Now let's move on to, trying to take this information, making it maybe a little bit more difficult with SYW. If you notice, it kind of has been helpful that I've been writing the numbers into the angles, because now if you look, all we have to do is add the two angle measures together. 76 degrees plus 40 degrees to get the grand total, which is going to give us, what's that going to be? There you go, 106. All right, let's move on to TYX. With TYX, we're going to simply add 64 and 76. So let's add those together. Give you a second to get it. That's going to give us 140 degrees. Finally, with VYX, VY and X, we're going to simply take 64 degrees and add it to 40 degrees to get our total. Which would give us 104 degrees. And I noticed now that I did make a mistake up here. This should be 116. All right, so go ahead and get started on your homework. We'll try to review that when I get back, and hopefully we won't fall too far behind.